Back, the binary search. This is another searching algorithm which can be used when the list is ordered. For instance, if the terms of list are numbers, then they are ordered from smallest to largest. If the terms of the list are words, then they are ordered in lexicographic or alphabetic order. In the binary search algorithm, the element X is compared to the middle term of the list. If the list is then split into two smaller sublists of the same size, or where one of these smaller lists has one fewer term than the other. The search continues by restricting the search to the appropriate sublist based on the comparison of the element to be located and the middle term. Binary search algorithm is much more efficient than the linear search algorithm. Let's explain this method for searching of 19 in this list. Notice what happens. So I'm searching for 19. So X is 19 and I'm searching for 19 in this list. A1 is 1, A2 is 2, A3 is 3, A4 is 5, A5 is 6, A6 is 7, A7 is 8, A8 is 10, A9 is 12, so on. Okay, as it's listed here. Now notice this is ordered. It's increasing in order. All right. There are 16 elements in this list. So how do you find the precise middle term? All right. You're comparing X with the middle term. Okay. There are 16 here. That means 8 to the left and 8 to the right. Middle term would be right here. There is no middle term. So who do you compare with? You compare with AM, where M is the floor of n plus 1 over 2. So the very first step, what are we doing? We are looking for M. M is the floor of n plus 1 over 2. N plus 1, 16 plus 1, 17 over 2. 17 over 2. 17 over 2 is 8.5. The floor of 8.5 is 8. Floor, recall, is the integer next to it on the left. So 8.5, floor of 8.5 is 8. M is 8. So compare your X with A sub M. So A8 is here. That's your middle term. Okay. So compare X with AM. In our case, X is greater than A sub M because X is 19, A8 is 10. All right. So X is greater than AM. So you start the search to the second half. So that's the first half. You start the search with the second half. So my search, new binary search, is from A8 to A16, which is, second half is A9 onwards, not, so that's the next one onwards, not A8, A9. So A8 until A8 is your first half, this is your second half. So 12 to 22. All right. Now you are comparing your X. X hasn't changed, mind you. Okay. X is still 19. Now you're going through the same procedure. Look for the new m. What is the new m now? M is the floor of, now this is your first term, this is your last term, you see. So what are you going to do? You need to find out the floor formula. You see, 9 plus 16 over 2. What is 9 plus 16? 25 over 2. 25 over 2 is 12.5. The floor of 12.5 is 12. So that's your middle term now. So you're comparing with 16. X is still greater than A sub m, because A sub 12 is 16. So now your new search is here. A13 onwards. So that is 18 to 22. All right. At this point, what is your M? M is the floor of I plus J. So 13 plus 16, that is 29 over 2. What is 29 over 2? It's 14.5. The floor of 14.5 is 14. So you are comparing X with 14. So X is equal A sub 14. You understand? A sub M. We found X. So you are going to return the location. If you hadn't found X, it would have been on this side or this side, and you continue the procedure. You notice how my list, initially it started with length 16, then it reduced to half of it, you see, length 8, and then it reduced to half of it. It keeps reducing. At some point, if X were not in the list, your I and J would interchange, you see, and then your search would end. Okay, if X is not in your list, then you would have location 0. Which brings me, what is I? I is the left endpoint. What is J? J is the right endpoint. As long as I is less than J, that is, you have an interval, you keep doing this search. The moment I is equal J or greater equals J, then your while loop ends. Okay, so let's read the pseudocode carefully. I hope you have a feel for how the algorithm works. It's called binary because you are precisely dividing your list into half, dividing it into 2 pieces. Okay, it is a very efficient algorithm. This is the binary search algorithm, algorithm 3. The procedure name is binary search. You're searching for value of, searching for X, which is an integer, in the list A1 through AN, which are increasing integers, increasing, okay? Start with I equals 1, J equals N. Left endpoint, right endpoint of your search interval. As long as I is less than J, look for the middle index. How do you find the middle index? I plus J over 2, its floor. Check, compare X with AM. If X is greater than AM, then you are starting a new search where the left endpoint has been moved up to M plus 1. Okay? Otherwise, your right endpoint, see, if X is not greater than AM, then X is less equals AM, in which case the right endpoint of your search interval moves down to AM. I hope it's clear. if x were instead of 19, it were say 6, right? So you're comparing x with a8. Well, x is less equals 10, so your search would land in the first half of the interval. Because initially in our first case x was 19, bigger than the middle number, your search continued to the second half. If your x were smaller than the middle number, then your search continues in the left half. That's all. So what does it mean to say left half? Well, left endpoint doesn't change, but right endpoint changes here. Okay, that's all you're saying. So if x is less equals the middle value, then right endpoint of your interval changes. Okay. Now, at some point, if x is ai, then you have identified the location. After going through this loop, you get only one thing. If x is that ai, you have encountered the location. If you haven't found x, then location is 0. Return whatever is the location. All right, so this was binary search. We will come to the next algorithm in our next video.